we are interested in the calculation of the power developed across 5 ohm resistance. Power developed across 5 ohm resistance. Where is the 5? Here is the 5. Is it right? But here is the load resistance here. Now think on this method how to calculate its value. Think on this method how to calculate its value. How is the procedure? Procedure will be the same. Be stick to your procedure. How is the case? The first point, we will remove the load resistance and redraw the same circuit. Redrawing the same circuit. Is it right? I will remove this and redraw the same circuit. How will be the circuit? It will be something like this. Is it right? This is A, this is B. 7 ohm, 6 ohm, 8 ohm, 2 volt, 2 ohm, and this is 7 ohm again. This voltage is 50 volt, this is 4 ohm, and this is 8 ohm. Is it right? Now, whatever it may be the circuit, how will be the figure? The procedure remains the same. Now, our aim is the calculation of the VTH. Look at how is the VTH. Our aim is the calculation of VTH, that is voltage between the points A and B. Yes, we will travel from the B towards A. We will travel from the B towards A. Use any path. Maybe this path, maybe this path, or maybe this path. Voltage will be the same. Is it right? But what I will do, I will use this path. In this case, my aim is the calculation of the current in these branches, 4 ohm, 8 ohm. Now, which method will be suitable to this figure? I will come back to you. I will take the answers from your side and then I will discuss. Yes, anyone? Which method will be suitable for the calculation of current in 4 ohm resistance and 8 ohm resistance? Yes. Akash, Avinash, Chaya, then Madhuri, Rishikesh, Ruchira, Saurabh, Shivani. Which method will be suitable? Anyone? We have the number of methods. I will discuss here. Now here in this case, we can use the mesh analysis. This is loop number 1, this is loop number 2. Or we can use the direct inspection method. This is one loop, this is second loop. We can find out the resistance of the first loop, second loop, common, and so on. Or we can also use the nodal analysis method. How many nodes we have for this figure? Yes, anyone? Saurabh?
2 nodes.
2 nodes. Yes, absolutely fine. This is one node and this is another node. This is one branch, second branch, and third branch. We can use the nodal analysis. I guess you are comfortable in the mesh analysis. इसलिए मैं mesh से solve नहीं कर रहा हूँ. Is it right? Because I know that. If it is loop 1, this is loop 2. Apply the KVL to this loop. Apply the KVL to this loop, and we are able to calculate the current in this whole loop. Or nodal analysis, I will use the nodal analysis here. This is the node A having its potential VA, and this is the ground node. This complete branch is 1. This is one branch. What is the definition of the branch? Path between any 2 nodes. This is one node, this is another. This complete is one path, I1. This is second node, second branch. Its current is I2, and this is the third branch. Its current is the I3. Is it right? It does not mean we can use the nodal analysis, we can use the mesh analysis, we can use the direct inspection, or you can use any other method which is known to you. Is it right? Now here again I will use the nodal analysis method. You can try by using the mesh also. You can try by using the mesh also. But here I am preferring the nodal analysis method. Is it right? Now applying the KCL at node A. Applying KCL at node A. If we are applying the KCL or Kirchhoff's current law at the node A, how is the KCL? This is incoming, outgoing, outgoing. This equation will be I1 is equal to I2 plus I3. I1 is equal to I2 plus I3. How much is the I1? How is the I1? This is 0. We are traveling in this direction, negative to positive plus 50. 0 plus 50 minus this potential, which is VA divided by resistance of this path. How much is the resistance of this path? I guess it is 19. Is it right? Which is equal to 7 plus 4, that is 11, 11 plus 8, which is 19. Is it right? Then I2 is the current in this vertical branch, which is VA divided by 6, plus I3 is the current in this branch. How much is the value? It is VA. We are traveling in this direction, positive to negative, which is minus. Which it is VA minus its potential, which is the 2. VA minus 2 divided by resistance of this branch. 8 plus 2, 10, 10 plus this 7 means it is 70. Is it right? Now, if we know the equation, simplify this equation and name this equation as equation number 1 and find out its potential. This is 50 divided by 19 minus it is VA divided by 19, which is equal to VA upon 6 plus it is VA upon 17, which is minus this is 2 upon 17. Is it right? Simplify this equation. I will shift this VA to the next side. I will take it as VA as a common. Then it is 1 upon 19 plus it is 1 upon 6 plus it is 1 upon 17. This is equal to this constant. I will shift to the next side. It is 50 divided by 19 plus 2 divided by 17. Find out the value of VA. How much is the value of this bracket? Yes, anyone? Yes.
0.27 VA.
0.27.
Yes, sir.
0.27 VA, which is equal to
2.74.
2.74 is the equation. And from this equation, this VA is equal to 2.74 divided by 0.27. How much is the VA?
Ten
Thirteen point 14.
Yes?
10.14.
10.14 volt is the value of VA. If we know the VA, in which current we are interested? We are interested in this current, I1. Is it right? Because my plan is to use this path. Yes, I am interested in the I1. I1 is equal to current in this complete branch. क्योंकि current एक resistance का नहीं होता. Current is for the complete branch. This is I1. How much is I1? 50 minus VA divided by 19. It is 50 minus VA divided by 19, which is equal to 50 minus 10.14 divided by 19. Find out its current, which is I1. Yes. How much is the value of I1? Yes, anyone? 2.09 amperes is the I1. Is it right? If we know the I1, find out its value of the VTH, Thevenin's equivalent voltage. It is a modulus value. We will travel from the B towards A because this resistance is connected between A and B. We are interested in this potential. Now look at the direction of the current. First I will mark the polarities. The direction current का कैसे है? Forward. This will be the plus, this is minus. This is positive terminal, this is negative. Then this will be the plus and minus. We are marking the terminals for this resistances or elements depending on the assumed direction of the current, but battery terminals are always fixed. Bigger one is positive, smaller one is the negative. If we are traveling from the B towards A, we are traveling from positive to negative, which is minus. 8 is the resistance into its current. Its current is 2.09. Is it right? This is one value. Then we are traveling from the negative to positive, which is a plus 50. Then positive to negative, which is minus. Again, this resistance is the 4 into its current is 2.09. Simplify this value and find out the VTH. That is Thevenin's equivalent voltage. Find out the VTH. How much is the VTH in this case? Yes, anyone?
Sir, 20.92 volt.
20.92 volt is the
Sir,
value.
24.92.
24. Yeah. This VTH is 24.92 volt. I will check with someone again. Yes. Anyone has the answer? और किसी के पास आंसर है? Yes. Chaurab. Unmute yourself.
हाँ सर करेक्ट है.
Correct. Ruchira.
Correct, sir.
Okay, fine. So if we know the value of VTH, the next step is the calculation of RTH. Now be careful while finding the value of the RTH. Is it right? Now look at how we will find out its value of the RTH, which is Thevenin's equivalent resistance. I will start from here. Is it right? Yes. For the calculation of RTH, load resistance is removed. And all sources are replaced by respective internal resistances. Is it right? Now how will be the figure? We will remove this load resistance, we will remove this source, and we will remove this source also, and I will redraw the same circuit. Here it will be something like this. Here is A point. This is the 8 ohm. This is the B point. It is the 7. This is 6. It is 7 ohm. This is 6 ohm. It will be the 8. This is 7 again. This is 7. This is 8. And finally, it will be the 2 ohm. This is 2 ohm. Is it right? This is 4 ohm and it is 8 ohm. The figure will be something like this. What I have done? Just I have copied the same figure. Just I have removed the load resistance. I have removed the sources by its internal instances. This source will be replaced by 0. This source will be replaced by 0. Everything will be the same. Now I want to know from your side, what is the series and parallel combinations? I will come back to you. What is the series and parallel combination? Chaya, your screen is minimized. You are not focusing on the screen, Chaya. Yes. So here in this case, if we are interested in this calculation, what is the series and parallel combination? Avinash. Yes. Yes.
सर 8 ओम एंड 4 सीरीज में
8 ohm and
4 ओम
4 ohm are in series. Yes. The next.
8 ohm 7 ohm and 2 ohm are in series.
8 ohm, 7 ohm, 2 ohm are in series. बिल्कुल सही. Is it right? Yes. I will take the feedback from someone else. Yes, anyone other? Ruchira. Are you aware of the series and parallel combinations? Saurabh. Yes. Here, I will, yes.
8 ohm 4 ohm and 7 ohm are in series.
8 ohm, 4 ohm and 7 ohm are in
Series.
series.
Yes.
No. I will discuss. Now look at the resistances, series and parallel combination depends on where we are calculating the values. Is it right? Now look at. यही तो confusion हटाना है. Generally, whenever we have the terminal something like this, always it creates the confusion. That's why first extend these terminals while finding the values. Whenever we are calculating the values, first extend the terminals little outside. Something like this. Is it right? If we are extending these terminals outside, then look at now, we are interested in the calculation of the resistance between these 2 points. Now, it cannot be in series with this. Is it right? Then these 2 resistances are in series, these 3 are in series, series is parallel, parallel is again series, and these both branches are parallel at this point. Always try to understand where we are interested in the calculation of the resistance. Depending on that, we can say that which is the series and parallel combination. Is it right? If we are redrawing the same figure, how will be the figure that I will draw? I will combine these 2 are in series. Now look at, this is my A point. Is it right? Here is the series combination. This is my B point. I am taking the terminals outside to avoid the confusion. These 2 are in series, 8 plus 4. It is 12. This is 12 ohm, right? Then, the 7 ohm I will keep as it is. The 6 ohm I will keep as it is right now. This is 7 ohm. This is 6 ohm. I will keep as it is. Now, 1, 2, 3 are in series and replaced by the single resistance, which will be something like this. 8 plus 2, 10, 10 plus 6, 7 is a 17. This is 17 ohm. Right? तो जब भी हमारा load resistance in between होता है, in that case, while finding the value of the resistance, which is RTH, always make a habit, extend these terminals outside first, and then try for the calculation of the values. Is it right? Otherwise, there is mistake in the calculation majority times. That's why here it is 12 ohm, right? Then this 7 ohm I will keep as it is, and these 2 resistances I will replace it by its parallel combination. It will be something like this. Here is A point, this is B point. It is the 7 ohm. And how much is the parallel combination of these 2? 17 is in parallel with the 6. How much is the parallel combination? Yes, I am expecting the answers from your side.
4.43.
It is 4.43. Now, how is the next figure? These 2 are in series. This here is A point. This is 1. This is another resistance, and this is the point B. Its value is 12, and this value is 11.43, I guess. Is it right? Now, if we know both values, then its RTH is a parallel combination of both. RTH is equal to 12 into 11.43 divided by 12 plus 11.43. Find out its parallel combination and find out the value of RTH. Yes.
5.85.
5.85 ohm is the RTH. Now, if we know the VTH and RTH, then complicated network will be replaced by the Thevenin equivalent network and calculated current and maybe the power which is asked in this case. What the thing is asked? Power across pi. We have to calculate the power. I will complete this first step. For the calculus asked, if we know VTH and RTH, then complicated network is replaced by Thevenin's equivalent network. How will be the Thevenin's equivalent network? This is the Thevenin's equivalent network. There is the point A, this is point B. Its RTH is 5.85, this is 5.85. VTH, which we have calculated, is the 24.92. This is 24.92 volt is the VTH. Is it right? This is VTH 24.92, and we are interested in the calculation of power in pi. This pi, which I will reconnect the load resistance, which is pi. I will reconnect the load resistance, which is the pi. This is pi ohm. And we are interested in the calculation of power in this resistance. First calculate the current. First calculate the current and then we will calculate the power. This is IL is equal to, this is 24.92 divided by 5.85 plus 5. First find out its current. How much is the current? Yes, anyone?
Sir, 2.29 ampere.
2.9 ampere is the current. Is that right? I will check with someone. Yes. Someone has answered?
Yes, sir, correct.
Correct. If we know the IL, find out the power. Sometimes it is known as power delivered to the load, power absorbed by the load, power wasted in the load. There are many terms, but equation is the same. IL square into RL, which is equal to 2.29. Its square into RL is the load resistance, which is pi. Find out this value.
26.22.
26, that is 26.22 watt is the power delivered to the load. And this is the calculation of the power delivered to the load by using Thevenin's theorem.